Happy day, everyone. Today I will be presenting my paper on the topic predicting close approaches and hazards of NEOs. So NEO stands for Near Earth Object. So it is basically a celestial body that appears to be outside of the Earth's atmosphere. So it can be an asteroid or a comet. So a celestial body can be classified as a NEO when its closest approach astronomical unit lesser than 1.3 astronomical unit. Okay, so my data sets near can be classified into two types, basically near Earth asteroids and near Earth comets. So this paper basically deals with only near Earth asteroids. NEOs are some of the crucial highlights that has to be known as NEOs are influenced by the gravitational pull interactions. Like they can be their orbit or the path, they can be changed. It is dynamic in nature. They can be changed. It is dynamic in nature. And then this paper uses only a few asteroids which has to be further observed or monitored to classify whether it is hazardous or non-hazardous. Okay, my paper deals with these following objectives. Distribution of the NEOs to their orbiting bodies, identifying and analyzing how many unique NEOs are there, and then how many times it is closely to approach the Earth's orbit, and then the NEOs closed approach details, including dates and hazardous classifications, and then building predictive models and comparing them with one another to find which model is more accurately going to predict. Next, these are the methodology which I have followed. First, I have collected the data, then pre-processed, analyzed predictive models, built predictive models, conclusion, future research. Data collection. So I have got this data set from the website called Kaggle. So it is a very open source network which is freely available for everyone. It is a discrete data set which has both which has both quantitative and qualitative data. And then moving on to the attributes. Initially, I had 27 attributes for integer type, 5 object type, 16 float type, 1 boolean, which is the whether it is a potentially hazardous or not. That is my target label, and then one daytime attribute, data time. Moving on to data preprocessing. So first, initially I've performed outlier reduction using the interquartile range and median absolute deviation. Then I have removed irrelevant columns such as near reference ID, name, limited name, so some irrelevant columns, and then used a feature selection done feature selection using the correlation analysis. So initially, this was this much outliers I was having, and then after performing the interquartile range in a MAD method, I've removed all my outliers. So the initial shape was 904 rows and 27 attributes. After removing the outliers, I have 596 rows. So basically, 308 rows were detected as outliers and they were removed. Then I have processed with the correlation. So here what I've done is, so there was totally 27 attributes. So I have done the correlation. The threshold, the features with threshold over 0.8 or equal to 0.8 is added into another data frame, and then I've used that data frame for further processing, and I've displayed the 8 attributes that I'm going to use for further processing of my data set. Okay, so now I have displayed the hazardous NEOs and non-hazardous NEOs count plot. So this there are 436 false, which is not hazardous NEOs, and 160 true, which is hazardous NEOs in this data set. Then I have displayed the total NEOs that are present in the data set. Also, there are 11 unique neos. Each neos ID, name, and count. Count means how many times it is going to be colliding with the orbit of the Earth. So that I have printed here. So here, the most frequent neos like 1865 Cerberus and 1862 Apollo occur 150 and 84 times respectively, and in contrast, less frequent neos such as 1960 Boreas and 1970 QO appears 12 and 15 times respectively. Then here I have displayed the orbiting for bodies for neos. So 0 stands for corresponds to Earth, 1 corresponds to Mars, and 2 corresponds to Venus. So here, from this, we can conclude that Earth is the neos mostly collide with the orbit of the Earth. Next, here I have displayed classified the neos as hazardous and non-hazardous with counts for Earth, Mars, and Venus. Earth orbiting body has the highest count for both types. Mars has fewer neos in both categories. Venus falls between Earth and Mars. Then I have displayed the asteroid which has already appeared in the current year. It appeared in May 3rd, which was actually classified as hazardous, but it didn't cause any damage to the Earth. Then for further studies, I have displayed the asteroids which may collide with the Earth's orbit for the next year. It is basically Toro and Delasis. Next, I've built 3 models of different nature, like KNN. KNN is a lazy learning method, and then naive-Bayes is it is predicted using probability, and then a decision tree, which is a branching method. So KNN has accuracy of 61%, naive-Bayes has accuracy of 96%, and decision tree has accuracy of 100%. So from this, we can say that decision tree is having a accuracy of 100%, which is overfit, and so moving to the next best model is naive-Bayes. So next, naive-Bayes can be used for predicting the data set, and then limitations. So here we are basically using a single data set, so which may not possibly cover all the neos. And then there are a few attributes which are lacking that may do a very great impact on finding the neos, whether it is hazardous or not. And then the model is tested on this learned data set. So if we have to further try it on other data sets to make sure whether it is working properly or not. And then some ethical implications of predicting dangerous neos need a more in-depth examination in the research. Then moving on to the conclusion. So here, from this, we can conclude that the Earth has the highest count for both hazardous and non-hazardous among the 3 celestial bodies. So a further examination has to be conducted, and a risk analysis has to be made. So this study highlights the importance of continuing to study neos as they possess a lot of risk to Earth. Our findings maybe could be used for improving neo monitoring and mitigation and detection statistics. Next, future studies. So this paper is basically about only on near Earth asteroids, but further studies can be conducted on near Earth comets. So we can what we can do is we can compare the near Earth asteroids with the near Earth comets, and come with a further outcome of which is more impact, which make more impact to the planets. Thank you.
Okay, thank you, ma'am.